All right, hi, this is Michelle. This is the second video on these notes on implicit differentiation. Implicit differentiation. Okay, so this is higher order derivatives. So this is implicitly defined, and then x and y are together on the same side. And the question is different this time. It's more challenging. Find the second derivative. So this is notation that means two derivatives, and each time it's with respect to x. All right, so we'll just take the first derivative, and then we'll take a second derivative. So let's take the first derivative. 6x squared minus, no product rule anywhere. So this would be 6y to the first times the derivative on the inside, dy dx equals 0. Okay, just like before, I'm going to isolate dy dx. It's pretty important. I could divide by 6 now. I guess I'll do it later. So negative 6y dy dx equals negative 6x squared. I'm going to divide by negative 6y now. So dy dx equals x squared over y. Because my negative 6's divide to 1. Okay, so I'm going to sort of, it's not my final answer, but I am going to kind of like lightly outline that, all right? Now to take my second derivative, the derivative of dy dx, so the second derivative, okay, I just want to keep track. So the derivative of dy dx is d squared y, because it's two derivatives, so d squared derivative over each time my independent variable is x, so dx squared equals, now how do I take the derivative of this? What rule do I need to use? I got power, product, quotient, chain. Quotient rule. Hello.
Hi.
Hi. Is this room in use this period?
Oh, no, I just, usually only the kids are in here, so that's why we're trying to figure out who's in here.
Oh, yeah, it's just me.
Okay.
Okay. Yeah. Sorry about that. So low is y, high is x squared. Okay. So d low, d high. Let's figure out what each of those are. So d low is dy dx, d high is 2x. Okay, so now I'm going to do the quotient rule. Low d high, so y times 2x. I'm going to write it with the coefficient and then alphabetical order. 2xy minus high d low, x squared dy dx over low squared. Okay, this is not my final answer. My final answer needs to have only, this is great so far, but needs to have only x's and y's on this side. So see how I have this dy dx? No good. I gotta replace that. Okay, so I gotta get rid of the dy dx. How can I get rid of it? I'm going to replace it with what dy dx is by substituting. So I'm going to use this and substitute x squared over y for dy dx. That's the big additional thing here. I mean, quotient rule was tricky, but this is the big, like you can't leave it like this. You must substitute this in. So 2xy minus x squared times x squared over y all over y squared. Okay, that's d squared y over dx squared. So now I'm gonna just make it have like not a be a complex fraction. So I'm gonna multiply by the reciprocal of the denominator. So 1 over y squared, 1 over y squared. This is a form of 1, so I'm cool to do it. So I'm gonna just do a little bit of that. So I'm distributing. So d squared y over dx squared. Can you still see? Yep. Equals 2xy over y squared. So this would be 2xy over y, I'll just write it all out. 2xy over y squared, okay? Minus, this is x to the 4th over y cubed, right? This term I can simplify just once, or I can put them all, I could put it all over y cubed, either way. I'm going to do d squared y over dx squared equals 2x over y minus x to the 4th over y cubed. That is my final answer there. Okay? That's my final answer. So the big thing is a lot of times with implicit differentiation, you'll end up with a quotient. So if you need to take the second derivative, you use the quotient rule. Okay? You'll always end up with a dy dx embedded within your answer of the second derivative. You must substitute for that. And then I multiply by the reciprocal of the denominator in order to get rid of the complex fraction. All right, let's do one more higher order derivative example. All right, so we're going to take the first derivative and then the second derivative. Try to see if you can do it on your own, and then check the video. Yeah. 8x to the third plus 6y dy dx equals 0. So dy dx is negative 3y over 4x cubed. Okay, so that's like my first, it's not my answer, but I'm just going to kind of like do a little bit of that. Now I'm going to take the second derivative of this. So I'm going to do low. So I need to assign the negative to something. I'm going to assign the negative to the top, I guess. So low is 4x cubed. High is negative 3y. Okay. So this is the derivative of this. It's just like negative 3, and the derivative of y is dy dx. So my second derivative, low d high. So 4 times negative 3 is negative 12. X cubed dy dx. So you should be thinking, I'm going to substitute for that later. Minus high d low. So this is negative 36. See what I did there? X squared y over low squared. So I could do parentheses squared. I'm just going to square it because I know 4 squared is 16. And x cubed squared is x to the 6th. Okay, so now I'm going to substitute in for dy dx. Negative 12x cubed times negative 3y over 4x cubed plus 36x squared y all over 16x to the 6th. Okay, so this I don't have to worry about the complex fractions. Those just cancel. 12 divided by 4 is 3 times 3 is 9. Is going to be positive. 9y plus 36x. Let me see. Can you still see? Yes. Okay. Plus 36x squared y all over 16x to the 6th. There's no common factors. My final answer to like all 3 terms. All right. So this is Ms. Schultz signing off. Okie dokie. Thank you for your attention. Bye-bye.